evaporation is mainly enhanced over the downslope side of the wind, and for the evaporation and sublimation field in the CD cross section cutting through a small hill, we can see a more symmetric structure between these two branches. So if we again do the same kind of the balanced integrated water budget and the vapor budget, we can see that for the inner core, after the typhoon making landfall, the PB, the ocean, the PBL source is much less because the typhoon is already making landfall after the land, so the evaporation from the low surface is much less. This is what we expected. And also, on the other hand, if we look at the precipitation field, we can see more precipitation is produced after the typhoon landfall compared to the situation over the ocean. And in particular, we can see that after the typhoon making landfall, there are more precipitation on the inner core compared to the outer region here. So if we do some kind of very simple backup envelope calculation in terms of the precipitation efficiency, this is what we found. During the oceanic stage, for the inner core region, if we define the size of inner core as the region between 0 to 50 kilometer radius, if we define the microphysics precipitation efficiency as the volume total precipitation divided by the total condensation. Here, condensation means the total volume integral of condensation deposition. Then the precipitation efficiency would be like 72% in the inner core. And however, over the outer rain band region, for the area with the radius of 50 to 150 kilometer radius, the total microphysics precipitation efficiency would be something like 57%. So for the rainfall efficiency in the inner core is much larger than the outer rain band regions. And however, after the Typhoon Nari making landfall, then for the inner core precipitation, because after the Typhoon Nari making landfall, the precipitation region is wider. So from the reflectivity structure, the inner core region Nara is defined as the radius between 0 and 70 kilometer radius. Then the total precipitation again is roughly the same as 72%, like the one in the oceanic stage. However, for the outer rain band region, then the total precipitation might not increase to something like 67%. So the precipitation efficiency is much wider after the typhoon making landfall for the outer rain band region. So these are the summary I have here. For the water budget of the Typhoon Nari, the ocean vapor source in the inner core region is only 70% of the inner transport into the Iowa region, and the 16% of the inner vapor transport into the outer rain band region, so respectively. And for the microphysics precipitation efficiency, defined as the ratio of the volume total precipitation divided by the total condensation and the deposition, which is about 70% for the Iowa region and 57% in the outer rain band region. However, after the Typhoon Nari making landfall over the northern Taiwan, the Iowa region precipitation efficiency remained roughly the same value of 72%. However, for the outer rain band region, the precipitation efficiency is increased from 57% to 63%. And this is consistent with the increased rainfall precipitation area over a wider region over the Taiwan topography. And this is for the Nari case. So for the Typhoon Morako case, we haven't done yet, but we would expect, because the Morako case, the outer rain band is much stronger, especially for the principal rain band embedded in the southwesterly floor. Then we would expect for the Morako case, the precipitation efficiency in the outer rain band region would be much stronger than the Iowa region. So because of the different structure of the typhoon, the precipitation region in the inner core and the outer rain band region will be quite different between Typhoon Nari and the Typhoon Morako. This is all I have. Thanks for your attention.
Questions? from 57 to 63% during the landfall stage. And with the major rainfall at that time stage still mainly over the ocean. And so why you see this change of 7% difference?
Yeah. I think the main concern is about the amount of condensation produced after the making rainfall, and also here, because we can see the condensation over the outer rainband region is still occupy a larger barrier here. This is all, by the way, this is in a relative unit, not an absolute barrier unit. So there is some difference in terms of the total condensation, because the total condensation amount is increased like 20 to 40% after rainfall. And another contribution is due to the transport of the horizontal water vapor flux. And because after the rainfall, this kind of amount of the transport is much less compared to the one over the ocean. And this will go back to the definition of the precipitation efficiency. So this is the total integrated precipitation value divided by the total condensation and the deposition. So this amount then that will change. So even though we can see an increase of the precipitation value, but if the condensation is increased further, then the ratio will be much different. So more detailed calculation will be done for the Morako case, and also in this Nari case.
Okay. Any more questions? Well, then we thanks Professor Yang, and then we move on to our